Hi everyone. This is the first video in a series on the basics of mathematics. We're going to go over the fundamental mathematical principles to make you fluent at math, so you can do the standard mathematical operations with any numbers comfortably without being unsure of whether you're following rules correctly or incorrectly. You're going to take care of all those sort of things. And what that is going to take is actually reimagining mathematics. You're going to look at it differently than how you looked at it before. And what this video will talk about is the fact that every mathematical operation, it's just addition. You've heard of addition, subtraction, multiplication, division, exponents, roots, logarithms. It's all different ways of discussing addition. That's what this video is about. So, you're probably familiar with something like 3 plus 4, which is the same as 4 plus 3. You can add things in any order, and that will equal to 7. So, addition is addition. Not much to debate there. Now when we get into subtraction, well, I'm going to tell you that subtraction is also addition. Let's say you have 7 minus 2. What's actually going on is you have a positive 7, and then you're adding a negative 2. And when you get, as a result of that, is a positive 5. Not how you're used to thinking about these types of operations. But here's what's going on. Every number is either a positive number or a negative number. Think of the sign in front of the number not as something that is being done to the number, but something that is a property of the number. This is a negative 2. This is a positive 3. If we don't put a sign in front of a number, that's just a short form, which means it's a positive, and because this number is in front of an equal sign or in front of the entire line, then we say, okay, we don't need to write that positive there as a short form. It's like writing it's instead of it is. So, think of it this way. You've got a weighing scale. But you've got these very special weights that can add mass or take away mass. So let's say on this side of the scale, you have a weight which is 2 pounds and another weight which is 3 pounds. Well, that's the same as putting a weight that is 5 pounds. Adding 3 pounds to the scale and then adding another 2 pounds to the scale, that's the same as adding 5 pounds to the scale. Or we can write that in short form. Without the leading positives, 3 plus 2 equals 5. What's really going on? We've got a positive 3, a positive 2, and combining them, adding them, that's the same as a positive 5. Now let's say we have these magic weights that actually take mass away. Let's say we throw one of them on that takes away a pound. We've added a negative pound to the scale. Now how much will that cup weigh? It's going to weigh 4 pounds. So a positive 3 plus a positive 2 plus a negative 1, that's the same as a positive 4. We're just adding up all of these weights. And if we want to write that in shorthand, 3 plus 2 minus 1 equals 4. Now if we add enough of these negative weights, the scale will actually start to tilt in the other direction if we don't balance things. So, let's say we throw on a negative 6. Well now, to balance that scale, what we'll have to put here is a negative 2. So we've got a positive 3 and a positive 2 and a negative 1 and a negative 6, and that's the same as a weight of negative 2. And if we want to write that in shorthand without the leading positives, we just have 3 plus 2 minus 1 minus 6 equals negative 2. So this is how we are used to seeing mathematical expressions written. On this side as well, what's actually going on is we are combining positive numbers and negative numbers. We're just not used to writing that leading plus at the beginning. And if we want to get really specific in our writing of everything being positive, and maybe you've seen this form of writing things before, plus 3 plus positive 3 plus positive 2 plus negative 1 plus negative 6 equals negative 2. Maybe you've seen things written like that before. And it is the same as what is written here, but that's just way too complicated. I don't like writing things out like that. I don't think you like looking at things being written out like that, but if it helps, then great, let it help. But essentially what's going on, subtraction is just adding negative numbers. So addition is addition, and subtraction is also addition. Now, let's go on to multiplication. You could find yourself in a situation where you need to add the same number many times. For example, 3 plus 3 plus 3 plus 3. Well, we've added a 3 4 times. Now we could fall into a trap here of thinking, well, no, we're adding 3 only 3 times. We've started with a 3, and then we're adding 3 once, we're adding 3 again, and we're adding 3 again. But remember, this is a short way of writing something. The long way of writing something is we have a positive 3, and another positive 3, and another positive 3, and another positive 3. We just have that leading plus to make things clear for us. So really, we're adding 3 4 times, because that first 3 is also a 3 being added. Another way of thinking of it is you're always starting with a 0. So you've got 0 plus 3 plus 3 plus 3 plus 3. Now, even if you use that shortcut without the leading plus, this is a lot of writing. A bunch of 3s. And we've only got 4 of them. What if we're selling 100 tickets, each of which is $3? Okay, so you have 3 plus 3 plus 3. Honestly, you're not going to write out all of those 3s. Maybe you'll do a dot, 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 and then you'll show, oh, by the way, there's 100 of them. Well, a shorter way of writing that is just 3 times 100. Sometimes it's written as 3 times 100 using the X symbol. Sometimes it's written with the 3 or the 100 or both in brackets. Many different ways of writing the exact same thing. But 3 times 100 is just 3 added to itself 100 times. Now, you can multiply in any order. So 3 times 100 is actually equal to 100 times 3. Now, why you can add in any order, why you can multiply in any order, these properties, I'll actually cover that in the next video. So right now, just take my word for it. You can add, you can multiply in any order. So multiplication is just addition. Any number A times another number B, that's just A being added to itself be times. Multiplication is just addition. So, addition is addition, subtraction is addition, multiplication is addition. Now we're going to talk about division. So, you might ask something like, well, 3 times 4 equals what? Well, that means add 3 to itself 4 times, and you get 12. Okay, so 3 times 4 equals 12. Now you might also ask a different question. You might ask, how many times do I have to add 3 to itself in order to get 12? It's still an addition question. You're saying, I want to add up 3 a bunch of times. I don't know how many times I have to add it up, but I want to add it up a bunch of times so that I get 12 as a result. How many times do I have to add it up? Well, the answer is 4. But how do we write that? So a question mark is on its own. Well, as long as we all agree on how to write that, we can agree on anything we want. The standard way of writing it is 12 divided by 3, or 12 divided by 3, different ways of writing the same thing, or 12 divided by 3 is what? When you say, what is 12 divided by 3? What you're saying is, if I want to get 12, how many times do I need to add up 3? That's what that means. And the answer is 4. Okay, let's say you have 25 divided by 5. Well, what does that mean? That means if I want to get 25, how many times do I have to add up 5? And the answer is 5 times, right? 5 plus 5 plus 5 plus 5 plus another 5, right? You add 5 up 5 times, that'll get you 25. So division is also addition. Addition, subtraction, multiplication, division, it's all different forms of addition. Now let's take it further. What if you have 3 to the power of 4? What does that mean? That means you're multiplying 3 by itself 4 times. 3 times 3 times 3 times 3. You're multiplying a number by itself a certain number of times. This is what we call exponents. Exponents are just multiplication. And multiplication, as we discussed, it's just addition. So, what's going on when we have 3 to the power of 4? Well, let's look at that 3 times 3. Well, we know what that is. 3 plus 3 plus 3. You're adding 3 to itself 3 times. And we call that 3 to the power of 2, because it's 3 times 3. You're multiplying 3 by itself twice. Now, let's look at 3 times 3 times 3. Well, what's going on? Well, we have that 3 times 3, the 3 squared, but we're multiplying that by another 3. So what's going on? We have 3 squared plus 3 squared plus 3 squared, right? We're adding it to itself 3 times. In other words, we're multiplying it by 3. Or 9 plus 9 plus 9, which is 27, okay? Or we could call that 3 cubed, right? We're multiplying 3 by itself 3 times. Now what's going on when we have 3 times 3 times 3 times 3? Well, we have that 3 cubed, and then we're multiplying it by 3. So what's going on? 3 cubed plus 3 cubed plus 3 cubed. We're adding it to itself 3 times, multiplying by 3. 27 plus 27 plus 27. Adding 27 to itself 3 times. And that will get you 91. Sorry, 81. So, exponents are just multiplication, and that multiplication you could just break down into addition. Now, just as with multiplication, you can ask an exponent question in a different way. We talked about how in multiplication, if you have, say, 4 times 5 equals what, right? If I add up 4 5 times, what do I get? Alternatively, you can ask, how many times do I need to add up 4 in order to get 20? You could do the same thing with exponents. You could say, well, if I have 2 to the power of 3, what do I get? And you can think about that and decide, okay, well, that's 2 times 2 times 2. And the first 2 times 2 here is 2 added to itself twice, which is 4. So this is 4 times 2. And that is 4 added to itself twice, which is 8. Right? Alternatively, you can ask, what to the power of 3 will give me 8? Right? What is it that I have to multiply by itself 3 times in order to get 8? So figuring this out, you want to say, okay, there's something that if I multiply it by itself 3 times, I'm going to get 8. What is that something? And you can scratch your head and think about it and realize, okay, well, that answer is 2. Now, how do we write this so that the question mark is on its own? Well, how you write it is the cube root of 8 equals what? Okay? And what that means is, what do I have to multiply 3 times, multiply by itself 3 times in order to get 8? Well, the answer is a 2. Right? Or let's say you have, well, what is the square root of 16? What does that mean? It means, what do I have to multiply by itself twice in order to get 16? And the answer is 4. Now again, that's just addition. What do I have to multiply twice in order to get 16? So something added up how many times? Well, the same number of times as that number is 16. In other words, there's some number a, and if I keep adding up a bunch of a's, a times, right? So if a is 3, I'm going to add it up 3 times. If a is 4, I'm going to add it up 4 times. If a is 5, I'm going to add it up 5 times. What's that a that'll get me 16? And it turns out that a value is 4. If you add up 4 times, you get 16. Now, is it always easy to think of a roots question as addition? Not always. I think it's easier to think of it as multiplication. What do I have to multiply by itself twice in order to get 16? But just so you know, you're thinking of it as multiplication, but that multiplication is just addition. And that brings you back to that concept that everything is addition. And roots, whether it's square roots, like the square root of 16, or cubic roots, like the cube root of 8, any root question is just multiplication, which is just addition. Now we have one more thing to cover. Addition is addition. Subtraction is addition. Multiplication and division are addition. Exponents are addition. Roots are addition. The one thing we have left, it also actually has to do with exponents. We can say 3 to the power of 4 equals what? Or we can say what to the power of 4 equals 81. Or we can say 3 to the power of what equals 81. Now these are 3 different questions. These are 3 different questions. They're all addition questions, by the way. But they are 3 different questions, right? In this question here, we're saying if we multiply 3 by itself 4 times, what do we get? In this situation here, we're saying, what do we have to multiply by itself 4 times to get 81? And another way of writing that is, well, what's the 4th root of 81? And the answer is, well, we worked through them before. 3 multiplied by itself 4 times is 81. You have to multiply 3 by itself 4 times in order to get 81. So the 4th root of 81 is 3. Just a review of what we just covered. This root question here is, what do I have to multiply by itself 4 times in order to get 81? And the answer is 3. And then the last question we can ask is, how many times do I need to multiply 3 in order to get 81? Right? So, in the first case, we know what we're multiplying. We know how many times we're multiplying it. What's the answer? In the second case, we know how many times we want to multiply something. We know what answer we want to get. Now what's the something that we need to multiply? The third situation is, we know what we're multiplying. We know what we want to get as the answer. How many times do we have to multiply that something? How many times do we have to multiply 3 in order to get 81? Now, the answer, you've probably figured out, is 4, but how can we write that so the question mark is on its own? Now, how you write that, it was something called a log. Log base 3 of 81 equals what? Log base 3 of 81 equals what? what that means, what that mathematical language means, is how many times do we need to multiply 3 in order to get 81? Multiply by 3 in order to get 81. And the answer is 4. As another example, log base 2 of 16. What that means is, how many times do I need to multiply by 2 in order to get 16? Well, 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. We've got 4 2's here. So the answer is 4. How many times do you have to multiply by 2 in order to get 16? 4 times. Log base 10 of 1,000. What that means, how many times do I need to multiply by 10 in order to get 1,000? Well, 10 times 10 is 100. 10 times 10 times 10 is 1,000. How many 10s did that take us? 3. So, log base 10 of 1,000 is 3. And what is 10 times 10 times 10? Well, 10 times 10 is 10 plus 10 plus a whole bunch of 10s. How many 10s do we have to add? 10 of them. You add up 10 10s, you get 100. 10 times 10 times 10, well, that's 100 times 10, which is 100 plus 100 plus a whole bunch of 100s. How many 100s are we adding up? 10 of them. Add up 10 100s, you're going to get 1,000. Right? That's our 10 to the power of 3 right there. That's our 10 to the power of 2 right there. So logarithmic questions, again, it's just an addition question. Everything is addition. Addition, subtraction, multiplication, division, exponents, logarithms, roots, it is all addition. And when you realize that, then it becomes much easier to understand all the mathematical operations and manipulation of formulas. All of these things become much simpler. So I hope that helps. Next video, we'll talk about different properties, like why you can multiply in any order, why you can add in any order. So until then, enjoy.